So, how many people here already have something running on 9.4? Okay, a couple of people. Yeah. Well, not necessarily. It only came out in December. So, how many people here are running their main stuff on 9.3? 9.2? 9.1? 9.0? Some EOL version of Postgres? How many people here are using an EOL version of Postgres for something critical? At least one of you is probably lying. Yeah. To be fair, I still have stuff that runs on Postgres 7.3, so. Anyway, okay. Well, it's time to start. I'm going to get started because I have a bunch of demos, and I want to have time for all the demos, because demos are a lot more fun than just slides. I'm going to talk a little bit about PostgreSQL 9.4. Before I get started, how many people were here for Josh Drake's presentation yesterday? Okay. Only a few people. Yesterday afternoon, Josh Drake. So I am not Josh Drake. I am the other Josh. I work for PostgreSQL Experts, Inc. I'm on the Postgres core team. As a matter of fact, the other Josh and I are a little bit different from each other. So this is going to be a different kind of a presentation. And for that matter, you know what? I love WebScale. I love it so much that you'll want to come to my talk on Sunday, which is going to be about the options for running PostgreSQL on AWS with benchmarks, and cost breakdowns and all kinds of other things that you do when comparing options. So that'll be fun. But in the meantime, let's talk about 9.4. Now, one of the things that we actually, before we get started talking about 9.4 is, some of you may notice that 9.4 got released a little late. Normally release new versions in September, and it kind of got released in December. And what happened there was in early August, somebody reported a major performance problem, actually a major data compression problem with the new JSON-B data type. And it took us a while to, first of all, work out what to do about this, because there were several different ways to solve the problem. And then it took us a while to actually implement that solution and test it and make sure that it worked correctly. And so all of that pushed back our actual release by about 10 weeks. That's what happens in open source. Our other option had been pulling JSON-B out of the release, which would really have not been very popular, because maybe not here, but up in Silicon Valley, which is where I work, I knew a lot of people who were using the beta in production. So would not have been a popular idea. So we went ahead and we just released late. So again, Postgres 9.4. This little logo and stuff came from a contest that we had. It's a little hard to see in the slide, but this is flexibility, scalability, performance. We had a vote on what was going to be the slogan of the new release, which will become relevant when I start doing my demos, because we did our election of the promotion for the new release via PostgreSQL, because that's the kind of people we are. But flexibility, scalability, performance kind of talks about what I'm going to cover. I'm going to cover a few other things. So for that reason, I actually call this talk FlexScalePerfSQL. And for anybody who's my age, you'll recognize that album cover otherwise. So FlexScalePerfSQL, and specifically what I'm talking about is, when I'm talking about flexibility, we're going to talk a little bit about JSON-B. For scalability, we're going to talk about logical decoding, streaming chain sets, etc. I'm going to talk about a bunch of performance features, and then a bunch of SQL features for you SQL geeks in here. How many people would consider themselves an SQL geek? How many people here don't like SQL but are forced to use it extensively on the job? So a few things. But first, let's talk about JSONB, our kind of headliner feature for 9.4. So one that we've also called this NoSQL on Acid, which was actually my personal favorite choice for our slogan here. The idea being that you can get some of the benefits that you would get out of a non-relational database without giving up the benefits of having a mature relational database. Now, one of the questions that people ask for this is, why is it a headline feature? Didn't we already have JSON? Wasn't a JSON data type a feature of Postgres 9.2? And it kind of was. But we did some things different after doing the initial one. The initial one was sort of the initial run, because we had the original sort of JSON type, but the original JSON type stored everything as essentially text. And that meant that, you could index specific keys using what we call functional indexes, where you create an index over a particular function. You couldn't index everything in the JSON column. And thus do sort of unspecified searches on the JSON column. You couldn't really do a lot of special operations over JSON, to treat it as a different type with atomic values and that sort of thing, and no sorting. So JSONB was created to fix all of those things. To actually, the B in JSONB stands for binary. It also stands for better. And in this, the JSON is actually stored in a specially structured binary tree within the varlena in PostgresSQL. And because it's stored in a way that has an internal structure that points to the various keys in the JSON value, it means that we can actually create a generic index over everything. And we can do key operations, things like has all of these keys and get me the list of keys from this as an array, and doing all kinds of other things. And because it is a normalized binary structure, we can do comparisons and sorting, and you'll see more of that later. Now, one of the things that we've done just to make life confusing for you is that we have retained the original text mode JSON type. And here's the reason that we did this. So the JSONB type does a bunch of things that are different from the old JSON type. That mostly these things are considered by most people to be features. But from a few people who built applications around the old JSON type, they consider them bugs, particularly because we actually restructure the JSON into a binary structure. We strip out things like white space, duplicate punctuation, duplicate keys are removed. If you actually feed JSONB a set of duplicate keys, it'll be a last in wins. The old JSON compresses a little bit better, loads stuff a little bit faster because it's not doing a transformation on the actual bits of the JSON. The JSONB actually implements the 4 primitive JSON types. The old JSON treats everything as a string once you've actually pulled it out into Postgres. And the problem was that we're getting ready to actually release JSONB, deprecate the original JSON type, and a couple of people spoke up and they're like, well, crap, I have applications that depend on my ability to load stuff with duplicate keys and significant white space into Postgres JSON types. So the old JSON type is still there, but I don't recommend using it unless you have a specialized use that requires these backwards, sort of bits of functionality. Now I did mention the JSONB is a binary tree structure. This is actually an early design diagram from when JSONB was being called HStore2. Anybody here use the HStore key value type for Postgres? A couple of people? So this is also an option for Postgres. It's keys and values. We've had it for a while. It's indexed. It's very fast, but it's flat. Only one level of keys and values. Can't nest. Not with any reasonable amount of effort anyway. It was being called HStore2, and so basically what we have in here is you have your value header, and then you have your sort of master header, and that points to where all of the top-level keys are. And then each of the keys may have a pointer to an area that has keys underneath that keys, and then finally to values. And it's done these days because of the whole compression thing. We use a combination of offsets and lengths in a fairly complicated structure, but it works pretty well. One of the other things that people asked when we introduced this is, well, those Mongo guys have this thing called BSON. Why don't you just use that? It's binary JSON, right? Well, a couple of reasons, a couple of problems with us using that. Number one, BSON is actually non-standard. That is, and specifically, it violates the JSON, the published JSON standard in several notable ways. And one of the things that we're into in the world of Postgres is adhering to standards when we can. And the other thing is that for Mongo, their BSON thing is this kind of weird hybrid of a storage and a communications protocol. And that wasn't really something we were interested in implementing. As far as we're concerned, JSON is a serialization format for a certain kind of binary, to get it in and out of this certain kind of binary storage, and not a communications protocol at all. So that really wasn't suitable for us, so we were sticking with JSON-B. So, from the other side of the house, from the dedicated DBAs and that sort of thing, how many people here are a professional DBA, primarily? A few people. One of the questions was, why do we need this? Why do we need this? We've got SQL, it's tremendously expressive. People should be constructing normalized databases anyway. So why do we need this whole JSON thing? It's just going to mess up my database. Well, one of my answers for that is, developers really seem to like it. Application developers really seem to like doing stuff in JSON and sort of a document-oriented model. Obviously, the commercial success of MongoDB is the tremendous case in point to this. They wouldn't be successful if people didn't want it. And a document model is a lot easier to understand than a relational model. You actually have to have some training or self-education or something to get what a relational database is about structurally, whereas anybody can understand the concept of documents. Also, if we're talking about web applications, the developers already know JSON because they use it in their applications, whereas they don't necessarily know SQL terribly well. And so they're a lot more comfortable doing things in JSON. And so that's one of the big reasons. The other reason, and this is the reason why I personally worked on it, because this was, a lot of stuff is driven by people scratching their own itch. It's open source, right? So I personally worked on it because we're building a lot of what we call sort of direct to JavaScript applications, as in a JavaScript application calls a thin shim of a web services layer. That thin web services layer makes a request to the database, which then returns a JSON blob, which gets sent directly up to the JavaScript front end or the cache, depending on where the request came from. And this has been, as somebody who does consulting for development, this has been tremendous because it has not just simplified our application design, it has simplified our communication with the web developers. We just have to tell them, show us what you want in JSON, and we will figure out how to get it to you. And that works in dealing with a separate web development team, and a lot of people are kind of in that boat. The other reason to have JSON-B is in order to get rid of EAV designs for extensible data. So for people who haven't encountered the term for this, a lot of people have done this without encountering the term. So here's what an EAV design is. ID, type of value. So, people ID 357, hair, brown. Lots of people do this, particularly the time that you find yourself always doing this in SQL databases, when you need data that is extensible at runtime, when you want to allow the user of the application to add new types of data to the database. Problem with the AV is it's hard to manage, it performs poorly, it takes up enormous amounts of space in the database, and doing questions like, show me all of the people who are over 45 whose hair is brown and are unmarried, those queries tend to also perform really badly because you're doing this over multiple rows and doing an aggregation operation. So if you need to extend data at runtime, if you need to provide an interface that allows the user to add new fields to the database effectively via the application, then JSONB can be a much better way to do that. You can also use HStore if it's relatively flat, but JSONB has the advantage of having 4 primitive types and allowing you to actually store nested data. So these are all of the reasons why we're excited about JSONB. Now, again, I was going to talk about some of the features of JSONB that's different than the old JSON type. And the big thing is your ability to create a generic index on the entire JSON column that you can then use for searches of the entire JSON column without needing to decide in advance which keys you want to search. So this uses Postgres' inverted index interface. Your standard, let's index everything in the column for whatever operation you do this, create index using gin. One of the searches, and I'll show you this, is called path search, where you're just looking for a particular key. You can create a generic index that only enables path search and doesn't enable other kinds of JSON operations. And the reason why you would want to do this is because that index will be about 2/3 smaller than the completely generic index. But you can do either, or both for that matter, although I'm not sure the planner will make the right decision if you do both. So this is awesome because it suddenly means that JSON is not just a way to store JSON blobs, but it's actually a way to store data that can then be searched on and manipulated. The other thing that we've actually added with JSONB is a whole bunch of operations. One of the problems that we had with the old JSON type was white space was maybe significant and maybe not, and application specific. And that meant that there was no equality comparison for 2 JSON values because you couldn't determine if they were equal or not. So now, because we are normalizing the JSON, we can determine if they're equal. We can sort the JSON. We can find extract key, do aggregation, do path search. Well, I'll have demos of these, which will be more interesting. The other great thing about this is that it just happens in developing all this. It didn't just happen. Oleg and Tiro put a lot of work into it. That this just happens to be pretty darn fast. This is some benchmarks that Enterprise DB did, comparing a very simple sort of document database and doing basic insert, retrieve, search operations on a single node Postgres versus I think a 3-node MongoDB cluster. And Postgres was the smaller is better on this. Postgres was kind of orders of magnitude faster. It looks a little bit better to see the numbers. That tells you a little bit more. So it's nice to, when you have a first cut at something, end up be this fast in looking for things and searching for stuff. So there's a couple of extensions before I get to the demo that you'll also be interested in. The JSON object extension contains a bunch of extra functions and stuff that will be part of 9.5 that just didn't make it in time for 9.4. And of course the PLv8 JavaScript language for Postgres to allow you to manipulate stuff. But first, let's do some demos, hey? So I've set this up. This is a little demo database that I constructed for doing lots of Postgres demos and that sort of thing. And I've set it up with, it's called libdata. And, hello, how about, no, that was not what I wanted. Oh. Does not like my piping command. Okay. So one of the first things to do, this is a small database. It's, I don't know, 60 megabytes or whatever. And so I have to actually disable table scan because that'll be what Postgres will do because it's such a small database. I just don't want to run a 60 gigabyte database on my laptop. So let's actually do some JSONB queries. So here's an example right here of a query where I'm just doing what's called a path search, where I am looking for, here, let's actually take a look at that table here. So this is a very simple table. This is an imaginary universe where Publishers in the library system are advanced enough to actually use something as modern as JSON-B for transmitting information about book titles. They do not. Anybody who's worked in publishing or the library industry will know that they use something much more primitive. But, and so we have these sort of import records that we are mining for information about books, particularly because the different publishers don't necessarily provide the same information about each title. And so for that, we just have the title and the ISBN of the book, and then this blob of JSON information that's pub info. So and just look like that. It's got a bunch of different fields and that sort of thing from the catalog in different formats. So then we want to say, okay, well, the first thing I want to do is scroll out of control. The first thing I want to do is we're going to do a count of all of the titles that we have from the publisher It Books. If I can take control of the scrolling. There we go. So there we go. We've got the path search. We're looking for the key publisher and the value It Books. And we see we've got 41 titles by It Books. Extracting that out of the JSON. So that's pretty good. So now, but one of the things is that we actually want to extract values as well. So let's go ahead and actually pull out the cost value, and that little bit of cartoon swearing right here, that operator, that says pull out that key and pull out the value for that key as text. Whereas if I just did that, that would be pull out that key and value as JSON. Sorry, I don't know what's... I need a better system for doing this, but I haven't found one yet. You haven't figured out a good way, though, to select out of a large file that's got a bunch of different steps?
Yeah, last time I did a presentation where I did this kind of thing, I just had it all set up so that it would know what to paste and everything.
Yeah, but the problem is that sometimes I do stuff out of order. So I need to actually be able to move up and down the buffer. I haven't figured that out yet. So here is, so here we've got the ISBNs, and we've extracted all of the cost values out of all of those JSON blobs.
One question on that. So you had what are the costs? Is that going to search down through multiple higher levels, or is that just one?
Yes. Yeah, except that it would have to search down. If I needed to search down through multiple levels, I would have to give it the path to that cost value.
Yeah, that's what I was wondering if that expression right there.
Yes, this expression is only looking for cost as a top-level key.
Okay.
So if cost was an inner-level key, I would actually have to provide it the full path to that cost.
Something like star as the higher level?
That is not supported, and I will be talking about that in a minute. That is not supported. Right now, you have to specify the full path, and there are no wildcards. So now, but we can do other operations. Like, for example, say that we were about to actually do some data mining on here, and we want to say, okay, we want to do a summary of cost by publisher. But first we want to check that the majority of the records actually have keys called publisher and cost, because it's JSON-B. When we took the data in, we don't actually know what's in it unless we define some ad hoc constraints. So, we know that there's going to be a cost in there, but some of the publishers might call it unit cost. They might call it something else. They might call it means. So let's make sure that we've actually got a bunch of stuff in here. And so now our little cartoon sorting operator, this question mark ampersand, that says, give me all of the value, give me return true for all of the values where they have all of the keys in this array. There's also one for where they have any of the keys in this array, which is question mark vertical bar, I believe. So, oh, oops, hold on. I actually have to quit the previous query. There we go. So there we go. We got 391 that have both of those keys, which should be enough to actually do some stuff with. So let's go ahead and do some stuff. And this is where it becomes an advantage to have, to have Postgres rather than some of the newer non-relational databases, because we still have access to all of Postgres' machinery, including things like sophisticated aggregates. I don't have an example here of doing windowing functions and CTEs with JSONB, but you certainly can do them. In this case, what we're doing here is I'm going to put the two things I just did together, and I'm going to extract the cost from the book's data value for every blob where the publisher is books. So just like we would do if these things were in separate columns. So there we go. Average is $35 for titles from books. But I actually want to say, hey, I want to see the totals for all publishers. So let's go ahead and do that. And here we're going to extract the publisher value, the cost value, and then do a regular group by. So there we go. We've got our averages there for each one here, including books and others. And we see that we see the problem with averages because either William Morrow is a really expensive publisher, or they've got like one book in there that's like $11,000, and it's throwing the average off. So we've got we've got all of our titles and that sort of thing in there. So, and you can do a whole bunch of other operations. Obviously we can just extract the whole JSON value out. Now, one of the things that I said that was a nifty thing that my colleague Andrew Dunstan did was that we can actually sort on this. And what it does, how the sorting works here, because here what I'm doing is I'm selecting the whole JSON blob for every books title, and then I'm sorting it by the entire JSON blob. And what that does is it sorts first by key name. So the keys are all strings, so it's going to sort by key name, and it'll go down through the tree of keys to do that. And then after it's sorted by key name, it'll sort by value, and it sorts by type of value first. I think it's booleans, then integers, then floats, then strings, but I'm not sure it's exactly that order. And then sorts by the value, like right here. Now, sorting just by the whole blob sort of randomly is not that good, because really what we're ending up doing is sorting by cost, and then format. So let's actually sort by let's actually extract one of the JSON values and sort by that, which would be a little bit more useful. And so now we have that same set sorted by publication date. Now, an important thing to keep in mind about JSON is that JSON, there is no timestamp among the JSON primitive types. So these dates are being sorted as a string. So if you're going to end up manipulating a lot of JSON data where you actually want the dates to do something sensible, store the dates in Unix format, or store them as integers. But you need to do something with them other than treating them as real timestamps, unless you're going to convert them back and forth from the timestamp type in Postgres in order to do your sorting. So, now, there was a question about wildcards. These were my first questions. So our indexing geniuses from Moscow are working on a future incarnation of this, which is called, appropriately enough, vodka for the indexing, because we have gin indexes, right? So now we need vodka indexes. And a sort of mini query language for JSON that they're calling jQuery. Because it actually turns out that name is not taken. It was a Java project called jQuery, but it's dead now. And so that will support things like path queries with wildcards in some sensible way. The work for this isn't done yet. We were hoping this would be in 9.5. They're not ready for 9.5. It's not going to be in there. So 9.6 hopefully. So now let's talk about our second part, which is scalability. The main scalability thing that got added to Postgres in 9.4 is this thing called logical decoding, which is a little bit cryptic. So let me explain it in more terms of what problem we're trying to solve. So here's the problem. Postgres binary replication is fast. How many people are using the built-in binary replication for Postgres for stuff? If you're replicating using, if you're using like Heroku or the read-only replicas for RDS, you're also using binary replication. So a few people. So binary replication is fast. It's fast and it's easy, but it has some issues. Number one, it is absolutely unidirectional. There is not even any theoretical way for it to go both ways, in a set. It has to replicate everything in your Postgres installation. So the entire Postgres instance, all the databases, all the schema, all the tables. You can't do anything selectively. You can't do any kind of writes at all in the replica, including temporary tables. And this is one of the most critical things, you can't use binary replication in order to upgrade Postgres. That is, you can't do a no downtime upgrade by upgrading the replica and then failing over. Doesn't work. So we actually did have older versions, replication systems, that didn't have these limitations, where you could do multi-directional replication or partial replication and upgrade by replication. But the problem was that those systems were slow and complicated and had an enormous amount of write overhead in the way that they worked because they were mainly trigger-based. So what happened was Andres and a couple of other developers went and said, if only there was some way we could read the binary replication stream and get a bunch of row updates out of that stream as a way to replicate. And so that is what logical decoding, the cryptically named logical decoding, is. It is an API which allows you to listen on the replication stream and turn it into SQL or row updates or protobufs or whatever replication system you want to use depending on your driver. And that means that you can then apply filters and transformations. You can send rows in multiple directions at once. You could have two servers, both of which are write nodes. Any of those things become possible. Now, part of the idea behind this is the ability to do bigger scale things like multi-master replication, or at least dual master replication, where you have multiple writable nodes. Doing replicating, like one of the things I do, because I do a lot of sharded Postgres for supporting web apps, being able to replicate different shards to different targets so that you can actually do round-robin distribution of shards in your cluster with failover. And most importantly, be able to do zero downtime upgrades. Now, an important thing to understand about logical decoding is that it by itself is not a replication system. It is an API for replication systems. So you actually need to put together logical decoding with a logical decoding plugin or driver and a replication management tool in order to actually get a replication system out of it. And that's on purpose because we already have multiple different and incompatible replication systems that people want to build using this mechanism. Two of the first are the big one, the people who develop logical decoding. Second quadrant are working on this thing called BDR, which stands for bidirectional replication. The idea being that you have peer-to-peer nodes, both of which can accept writes, or all three of which, or all four of which can accept writes, and they can send row versions back and forth and reconcile conflicts. Sloaney, if anybody has used the old Sloaney replication system, they're revving it so that you can still use Sloaney and it gets rid of all of the triggers, which was a big part of the disadvantage of using Sloaney, and can now use the logical decoding system. And so that'll be more standard single master replication, but it'll be single master per table, giving you a lot more flexibility and the ability to do things like upgrades. Now, one of the other things that we got as kind of a side effect of this is something called replication slots. And in order to understand why we need replication slots, I saw not a lot of people using binary replication here. So one of the things with binary replication is the master needs to keep a certain amount of data around in case the replica gets behind and has to ask for old changes. And the problem, our previous way of configuring this is you actually allocated a fixed size buffer or created a storage archive. But if you're just relying on the master to do this, you allocate a fixed size buffer called wall keep segments. The problem with that is that means that you're keeping that size buffer around whether or not anyone needs it. And if you go even 16 megabytes over that buffer, it's no good. You're out of sync and the replica can't catch up. So the idea with the replication slots is that you assign a slot to each replica, and the master keeps track of what data that replica has seen or not seen, and keeps as much data as the replicas need. Another scalability feature that we got, adding to replication, is standby delay. This was something that a lot of people had implemented via a hack. That is, time-delayed replicas, a replica that is deliberately always 2 or 3 hours behind. The biggest use for this is in auditing systems and security, where you have a certain window where you have to be able to react to an intrusion or to improper behavior or to drop table users and then jump on the replica and halt replication before that comes down the pipe. Or simply for an auditing system, you have an external system that constantly compares the versions of stuff on the replica with the versions of stuff on the master in order to implement certain kinds of auditing. And so this is now an actual feature that you can just set in your replication configuration. So before we get to performance, let me do a couple of demos. So, like I said, logical decoding is at this point just an API. Hold on. It's just an API, which means that what I'm going to show you is actually our sort of debug testing version of it, to actually show you how it works. So the first thing you actually have to do is you have to create a slot. And when you create the slot, you have to enable a plugin. And in this particular case, I'm using the plugin test decoding. The reason why you need a plugin is, depending on how the replication information is going to be interpreted, you need to actually have different C code to convert that into whatever statements you're running. So, and in this case, we're just using the test decoding debugging one, but if you're using something like BDR, you would have the BDR plugin, and that's going to be a shared object library that you install on your system through a package. So we've created the slot, which is at a particular log position. And so then we can actually start making some changes. We're going to actually update some records here. So, and so now, because we're doing test decoding, we can actually see this in our own session. Now, obviously, in a real replication system, we would be querying this information on the replica, not on the master. Although you can see why, you'll see why when I actually do this, that the other project that's coming out of this, that's becoming part of 9.5, is something called PG Audit. Because it's useful if you need to have auditing for PCI or HIPAA or whatever on your system. It's useful to be able to see a stream of all of the changes that have happened, regardless of where they happened. So now if I actually check the changes here, I can see I get a series of these, and this is a debug format, so it's meant to be human readable so that you can actually debug it. Any of the real plugins would actually be using a machine readable format and not a human readable format. And you can see that we actually did a whole bunch of, and here's the changes and here's our commit, right? So what do you think will happen if I run that query again? What will I see? Anybody know why that happened? No, it's because I've already seen the data, and the master knows I've already seen the data. So it's not going to send it twice. And that's the whole point of the replication slots, is to make sure that you don't send data twice so that we're not duplicating the same set of changes on the replica repeatedly. In order to actually see more changes, I need to actually do more changes. So then if we actually look at this again, we can see now we've got the delete statement in there as a transaction. So that actually goes there. Now, one of the important things about replication slots is, remember how I said this allows the master to hold on to change data that's needed until the replica needs it. Well, this provides you with a great opportunity to run your master out of disk space, because it will hold on to that data until the replica needs it. So you need to, at some point, tell the master, hey, by the way, that replica 1, that machine is dead. It's never coming back. And therefore, please stop holding on to data with it. Basic way to do that is to just go ahead and drop the slot. So I'm going to drop the slot. And that is our basis for logical decoding. Oops. Hold on here. There we go. And you will see more exciting things in the next 9 months or so, both as BDR advances and move into 9.5 and PG Audit and a bunch of other things. Like I said, right now it's an API, it's a construction kit. The exciting thing will come as tools, as people build stuff on top of this. Maybe some of you. And it would not be a PostgreSQL release without a whole bunch of performance improvements. One of the biggest one is that we've sped up our GIN indexes, or more Alexander Korotkov primarily, I believe, sped up the GIN indexes by making them smaller and faster. So up to as little as half the size, as much as 4 times faster, to the point where you frequently may want to use a GIN index. It used to be the case of, by the way, GIN stands for generic inverted indexes. These are inverted indexes. We use them in complex values. It's the same indexing algorithm that's used by things like Elasticsearch. So we use the inverted indexes in there, and now they've gotten so much faster that in a lot of cases they're faster than B-tree indexes, the standard B-tree indexes. And this also means that Postgres we're never ever going to fix our built-in hash indexes, because now there's really no point in using them, because we can just do hash over GIN index and it's faster. The faster wall inserts, the write-ahead log for Postgres is how we guarantee crash safety, and so obviously performance contention on the write-ahead log is a big part of Postgres performance in general. We've got better concurrency on that now, made it quite slightly smaller in general, which is important because the new replication system adds extra information to the log, so we needed to actually shrink it in other ways. The result has been that I did some benchmarking early on for 9.4 for write-heavy disk-bound workload that I came up with for a client's workload, actually, and I got about a 20% performance boost for that right out of the gate, running 9.4.0. Support for Linux huge pages. How many people here have more than a quarter terabyte of RAM? Anybody? Wow. Nobody. Okay. As you move into bigger machines, you're going to want huge page support from Linux or whatever systems in order to make effective use of all of that RAM, and now that it's supported by Postgres. And materialized views. So we actually added the materialized view feature in 9.3, but we didn't talk about it much because it wasn't really useful, because it was missing some things. And some of those things have been put into 9.4 enough to make it useful, particularly the refresh materialized view concurrently. Now, the idea of a materialized view is a regular view is a saved query, right? You run a saved query that you can run at any time by just calling it as a table. But sometimes that save query is complex and long-running enough, like it's, say, doing a summary of millions of records, that you don't actually want to rerun it every time you want to refer to the data. And for that reason, you actually want to store that somewhere. Now, you can obviously just copy it into a table, but the materialized view concept gives you a better syntax for that and a way to separate your materialized views from your actual data tables. So let me actually demo that. And the way that I actually want to demo that is by showing you the little database that I constructed for our survey for slogans for 9.4. Now, this was done by importing a Google survey. And the problem with the Google survey is that it gives you this sort of spreadsheet view. I mean, it's a spreadsheet of your data, but that's not very good for doing summaries and comparisons of different statistics. I really want a more vertical view of the data. So I'm going to go ahead and create a materialized view. And now I can treat that as a table because it's being stored as a table. As a matter of fact, because it's being stored unlike a dynamic view, I can actually even create indexes on it. And then I can actually do computations on some of these. Like I can say, what was the average vote for each slogan? And look at it that way. You know, we're looking down here. Here were the different slogans we voted on. Here were the different average votes. And it looks like performance, reliability, flexibility pulls a little bit ahead in the average, but that's hardly a deciding factor, so we're going to do some more statistical analysis later on. I'm not going to show you refresh materialized view concurrently because we're actually running a little bit behind time, and I want to show you some other stuff. So let me show you some other stuff. Now, I'm a big SQL geek. I do a lot of stuff on the SQL command line. I do a lot of stuff by writing SQL code. So I'm actually, believe it or not, a little bit more excited about other features that were less headliners in 9.4. One of these is alter system set. And what alter system set allows you to do is to change a configuration parameter in Postgres, not just temporarily in your session, but to actually write it to disk so that it is persistent on Postgres for other sessions. And this is called alter system set. So this has been part of a progression of different ways to configure Postgres. First, you're going to edit the pg.conf file. Then you can add include files, and you can add an include directory in 9.3. And now you can actually modify the config file over port 5432. And one of the big answers is, why would you want to modify the configuration file over your Postgres connection? Why would that be a good idea? Does anybody guess on this one?
For the cloud.
Well, actually, specifically, this is why I'm interested in it. Because one of the ideas of the sort of new container cloud stuff is one container, one service, which means I don't want to be running, as we saw presented earlier on, one of the things you don't want to be doing is running a separate SSH daemon and full init system on your container if you can avoid it. And for that reason, I want to actually be able to do everything over port 5432, and alter system set is a step in the right direction. Second thing is something called filtered aggregates. How many people have written an aggregate query like this? A little bit? Not? So this is your standard, I want to do a count of everything by some other thing. And it's ugly and it's awkward and it's very easy to accidentally get wrong because you put the case statements in the wrong order. So I think this is David Fetter, wasn't it, for this one? Went in and did this, which is actually in the SQL standard, which is this filter clause. So you can now, to any aggregate function, you can apply this filter clause, which currently only takes a where clause parenthetically, but in the future we might add other things that it supports. So you can say, that is equivalent to this. And it is much more readable and much more maintainable in your code, as well as under some circumstances a little bit faster. The next thing that I am really excited about as a big data sort of statistical guy is something called within group. And the idea within group is that it allows you to actually do what are known as sorted aggregates. That is, ways to sort aggregates that require your results to be ordered. So in here, what we're doing is we're selecting a percentile, that is a percent of the set. We're actually selecting an array of percentiles, 0, 25%, 50%, 75%, 1, within a group, and we're giving it an order. Generally, you're ordering it by the value that you're actually doing the operation over, but not always. And does this set of values look familiar to anybody? Anybody here do statistics or analytics, does data analysis? So what is that set of values? Yeah, exactly. And that's something I do all the time. And I've been doing it in PL Python up until now, and now I can actually do it in core Postgres, and it's much faster. Hello. Now, one of the other ones that I may or may not get to demo to you, this is easier to explain if I actually demo you, is multi-column unnest. So, now, I'm going to go over to the demo screen. So, we've got about 10 minutes left. Let's take a quick vote. How many people would prefer to see, we can either do more demos or we can do questions. How many people would prefer to see more demos? A lot of the SQL features. Yeah? Okay. More demos. How many people would prefer to ask questions? Okay, demos it is. So, now we've got our slogan database, and like I said, the thing I always hate about the average, well, actually, wait, we'll do a few other things first. First, I'm going to show you alter system set. So here we've got alter system set. Now, you notice I've actually got two statements here. So the first thing that I actually do here is alter system set. There. But if I do, you notice my work mem has actually not been changed. And the answer to that is that alter system set system simply wrote it to disk. It did not change it in the current session. You actually have to call a reload config in order for it to change it in the sessions. And the reason for that is it was our way of working out the issue that often if you're going to be changing settings this way, you want to change a bunch at once, and you don't want to take them effect until you're done changing settings. For something, some settings are dependent on each other. And so you actually go through this thing of doing an alter and then a reload config. Now, as I said before, averages are not very trustworthy. Like we saw with William Morrow, one really high value can throw the average way off in completely misleading ways. So what I would really rather have for determining which is the most popular slogan is let's look at the median here. So let's actually get a median for each of those slogans. So we've got, and now here again, we're seeing actually a real pull ahead for performance, reliability, flexibility, which was the original version before we changed the order of things. That is a median of 4, whereas the others all have a median of 3. So on average, people really liked it, or liked it more than they liked the other slogans. Now, I actually, like I said, I like to do a full box plot of a lot of things. This is obviously more interesting with more discrete data rather than a 1 to 5 vote. But you can actually sort of see the distribution there. This returns an array. It's got the distribution, and you see actually part of the reason that performance, reliability, flexibility did so well is that very few people gave it a 1, which is I hate it. But let's actually see how many people hated things versus how many people liked things, right? So a 1 is I hate it, a 5 is I love it. So I want to actually do aggregate filters, count filter where vote equals 1 equals vote equals 5, in order to see how many hates and loves we have for each slogan. So there we go. So if we look here, we see some patterns like, for example, performance, reliability, flexibility did well because it had a lot of loves and very few hates. And no SQL plus YesQL was really widely hated. Hence its low score. So we're actually like trying to decide, in deciding which would be the slogan, the answer is to actually put all this together, and we're going to look at the median and the number of loves and the number of hates, and that is actually our sort of total score for all of the stuff here. And again, we see how we ended up with the slogan that we have, because that wins on all of the different ways of looking at it. Now, I actually have to switch to a different database. Oops. In order to demonstrate the little nest thing, this is actually kind of cool. If you do a lot of arrays in Postgres, and this was actually, the whole feature came out of a discussion I had with Andrew Geerth about a project that I was currently doing. And in this project, we receive a lot of data from the sensor data from the field. And the sensor data comes in an ordered way, but we only periodically have timestamps. And so we'll have like a minute worth of data, and we know that data all came in a certain minute, and we knew that it came in a specific order, but we don't know where in the minute each one of those things came in. And so in order to make the data reflect the reality, we store the data in little arrays, which also has some other advantages in terms of doing calculations. But a lot of times we want to say, we're going to take, say, the speed data and the temperature data, and we want to make those arrays more or less line up. So the first speed observation is next to the first temperature observation, and the your second one is next to the second one. Now, previous versions of Postgres had this thing called unnest that you could call in order to turn an array into a column. But the problem is that if you have multiple arrays, there wasn't a straightforward way to turn them into multiple columns. And this unnest feature, together with a bunch of other improvements in table functions, allows you to do that. So here you see a construct that you probably haven't seen before, which is a lateral join. Because we have right here, select, the observations timestamp, and then some synthetic value from observations, and then we're doing this lateral join against an unnest over two fields in the table. And then we're adding this other new clause called with ordinality that gives us an ordering, so we know which order it was, which number it was, so that when we say decide to roll the arrays back up, we can roll them back up in order. So we can actually pipe that to terminal, and we see these observations where we've got our speed and temperature observations next to each other. And if you start looking at this, in this case, this is a vastly simplified thing of something we were actually doing. These are wind turbines, and what we were looking for was how quickly they heat up when they speed up. And doing the observations, and you can actually, and now that we actually have stuff in rows, we can actually kind of make those correlations, use a windowing query to compare the speed times the time, and look at what the delay is between the speed up and the heat up. So, unnest. So those are my fun demos. So, 9.4, the most awesomest PostgresSQL ever, at least until 9.5 comes out. Some other things I need to plug. March 10th, Burlingame, California, SFPG Day, another full day of Postgres stuff. This is co-hosted with FOSS4G North America. So how many people do PostGIS or geographic stuff? Anybody here? A couple of people. So if you're doing PostGIS, you want to actually sign up for the full conference. So a full week of geographic stuff, including a day of Postgres and PostGIS. Registration is still open, and it's a $100 flight or a 6-hour drive away, right? I come to my talk on Sunday, and otherwise I'm done, and I'm pretty much, actually I've got 3 minutes left. So, questions? Will your slides be online? Yeah, the previous version of this is already on SlideShare, but I'll put an updated version on there at some point. No, yeah, I would stick that on GitHub. I'm trying to remember if I already did. If I didn't, I should, but it also needs the Docker to go with it, and I think that's actually what caused me to hesitate. There's no permissions for access to alter system. You need to be super user. You need to be super user. And one of the other things that people have asked about is how you block alter system set. So alter system set writes its stuff to a file called postgres.auto.conf, which is in the Postgres' data directory. not the configuration directory if those are separate. And the answer is you just change the permissions in that file so that the Postgres system user does not have write access to it. And if you do that, it'll block alt-system set if you don't want people using it. Of course, the real answer is don't let people log into the super user if you don't want them to do those things. But because the truth is, if they can log in as the super user, there's system functions that would allow them to do things like overwrite files. So, more questions?
I'm guessing the answer is yes, but can you join onto JSON
Yes.
tables?
Yes. Because what you would do is you would just evaluate, you would be joining on a key, really, right? I mean, you could actually join on two JSON fields if the JSON was identical between the two. And you could just join in the whole field because JSON B, we have equality. Can't do it in JSON, can't do it in JSON B. Or you could extract keys. You could say, I want to join the publisher key in here to the publisher key in there. And yeah, it's going to be slower than joining on a regular column, but it'll certainly work.
So then my kind of layered question on that would be, is there advantage and does it make sense to do a materialized view on that?
Well, that's going to be performance specific, right? As in, if it takes the query a long time to run, here's the thinking on materialized views pretty much always. If it takes the original query a long time to run, but the data doesn't change very often, then a materialized view can be a good idea. If the data changes frequently and the query doesn't take very long, a materialized view is almost certainly not a good idea. More questions? We got anybody else? Yes?
Do materialized views automatically update, or do you have to do a call?
You have to do a call right now. There's been talk about adding various forms of automatic updating. So I mean, right now what would be easy to implement is either a trigger to do synchronous updates, or a cron job to do timed updates. There's been talks about doing more sophisticated things that would be more automatic, but we need a fair amount of underlying machinery in Postgres first before that happens.
Attach it on top of your replication thing.
Yeah. Well, that would actually be something you could do. If you had a replication plugin that included materialized view population, you could certainly do that.
Well, I was saying the binary replication monitors you guys just hooked up, you're saying there's all sorts of applications for it.
Yeah. Yeah, so it's actually, yes, you could do that. You could use logical decoding, see whenever the table changed via logical decoding asynchronously, and so update the materialized view asynchronously but close in time, which is something that people often want. So yes, you could absolutely do that. More questions?
The materialized view is session-based, or it will stay there when I come next time?
Materialized views are stored. They're available to anybody who has permissions on them.
I was curious how much do you see analytics being done in core Postgres, or the want to do so?
A lot. More than should, frankly. Mostly because people are often reluctant to make the leap to an expensive proprietary system. With Postgres SCaLE coming along and Greenplum being open source, I think that'll change. But we have a lot, I mean, at least for like my consulting practice, a bunch of our clients, the clients that are not scalable web apps running on Amazon, are often, your small to medium-sized data warehouses. Because actually, if you have like a terabyte, 2 terabytes of data, Postgres actually does a pretty good job of being an analytic database. It's at larger sizes that it starts to suck.
It all depends on your team on how bad it's going to suck.
Well, it depends more on what kind of requests you're asking, right? Because I have clients who have 500 gigabytes of data, but almost every report they run aggregates 300 out of the 500 gigabytes, and so that's pretty slow. Whereas I've had other clients who are mainly doing compliance archiving, and so like I've had one client who literally had a 93 terabyte Postgres database, but they never retrieved more than one row at a time out of it, so it worked fine. Couldn't back it up, but
on Reddit somewhere, on Reddit, PostgresSQL room, I read that Skype uses PostgresSQL, and then they got purchased by Microsoft, and Microsoft left it PostgresSQL.
yes. As far as we know, they haven't changed the underlying basis of it. The Microsoft has actually been promoting PostgreSQL in the Azure cloud, so they probably won't change it. Anything else? Okay, well, thank you very much. And what time is our next session?
Starts at 5.
Okay, next session starts at 5. So see you then. Oh, and it's yours, too. Yeah?
I sent you an email for the PostgreSQL Docker container that I created.
Just move
Oh,
that
okay.
set up.
ago. Maybe it could come in handy for you.
Okay. Well, I mean, is it, maybe.
It has a lot of things installed in there, like PG Hero and stuff. You know, it's more of a
PG Hero?
Yeah, PostgreSQL Hero. It's a web interface to Postgres
Okay.
for to be able to see performance and stuff like that.
Okay.
There's a lot of goodies on there.
Okay,
And
cool.
PG trees and all kinds of other tools. I just compile it, not for like a production environment, but
Yeah.
just to
Okay.
as example and for.
Okay, yeah, that would be cool. I mean, I guess part of it depends on stuff like, how you want to do things, because the sort of doing stuff by the kind of Docker way. Oh, you know what? I should take the mic off.
I tried to stick to the convention. I
Yeah.
left a lot of the steps out of the Docker file. I kept the Docker file to be
Hold on.
as short as possible, and I basically offloaded a lot of that stuff.
Yeah.
Inside there, it does all the rest.
Yeah, I mean, they would just, for a lot of the things, they tend to say, okay, we want to run Postgres on one container and PG Hero on another container.
Oh, yeah.
Yeah,
In that case. It's just this one I installed it.
yeah, they just do everything, yeah.
Yeah.
Yeah?
If you look on a local application and you are using SQL, you get
I mean, you wouldn't really use SQL to get it out, but yeah.
Oh,
That's the downside.
Oh, okay, yeah.
That is our debugger to say, the only reason test decoding is there is to say, hey, is logical decoding even working? But it's not actually anything you use for replication.
Okay, yeah, because I just saw, hey, what happened in the SQL trail.
Yeah.
So, you connect to the API and get the bytes, I mean, that's right?
Yeah, and so the thing is that you use a specific plugin designed to do the replication feature. So, like, if you're doing BDR replication, BDR has its own plugin, and it has its own binary protocol that it uses in order to be the road. Because obviously, I mean, even like a text protocol would not work. Like, imagine if we actually had a blob on it, right? Images
So
don't work that.
I mean, Postgres is getting better and better.
Yeah.
About a good source of best practice.